Hi, number crunchers. Let's talk about similar triangles. So we already know that congruent triangles have the same shape and the same size. Similar triangles are a little bit different because they have the same shape, but not necessarily the same size. So triangle 1 and triangle 2 have the same shape. They're both wide at the bottom and not very tall. They're similar because their angles are all the same and their sides are what we call have the same ratio. So this side A over D has the same ratio as B over E, and similarly C over F have the same ratio. So we have three ways of proving triangles are similar. They can either have two corresponding angles that are equal. They can have three corresponding sides that have the same ratio, or two corresponding sides that have the same ratio and their included angles. This is important. So let's look at the first example. So in this first example, Shiloh wants to shrink his triangular business card logo by a scale factor of 15:2. So that means that our bigger triangle is going to be a ratio of 15:2. The original business card had measurements of 60 centimeters, 45 centimeters, and 30 centimeters. We want to figure out what the smaller version of the logo is going to be so it can fit on the business card. So we'll set up our three ratios in a proportion. I've got 60 here, 45, and 30. So in order for them to be similar triangles, I need to have the same proportions. Since 15 times 4 is 60, I'll do 2 times 4 to get 8. Since 15 times 3 is 45, I'll do 2 times 3 to get 6. Since 15 times 2 is 30, I'll do 2 times 2 to get 4. So therefore, since the original side of 60 is now 8, the original side of 45 is now 6, and the original side that was 30 is now 4. For this next pair, I know that I've got some corresponding angles that are congruent because I've got these two parallel lines. I know that this angle and this angle will be congruent, and this angle and this angle will be congruent. And of course, this angle is congruent to itself. So I know that I've got two similar triangles. In order to solve for x, I can use this side angle side method. So let's set up our proportion. I know that this 14 side is corresponding to the 6 side. Here's where I need to be careful in this part of the proportion. I know that this corresponding smaller side is x plus 2, but this longer side will be 3x minus 3 plus x plus 2. So when I add those together, I get 4x minus 1. When I cross multiply, I've got 6 times 4x minus 1 is equal to 14 times x plus 2. I end up with 24x minus 6 equals 14x plus 28. I subtract 14x from both sides. Add my 6, which gives me 10x equals 34. When I divide by 10, I get x equals 3.4. Let's do one more example together. So in this example, we're asked to circle the two triangles that are similar. So I want to figure out which ones have similar ratios. So it looks like these guys are corresponding. So if I do 35 over 25, let me see if I get the same ratio as if I do 49 over 35. When I simplify this guy, I get, and divide both the top and the numerator and the denominator by 5, I end up with 7 over 5. If I do the same thing for 49 and 35, I end up with 7 over 5. I divided both the top and the bottom by 7. If I go to 28 over 15 and check that, I can't divide both of those by the same number, so these guys are not similar. Next, I'll move to check these two. So first I'll check 25 over 15. That simplifies to 5 over 3. If I check 35 over 21, I can divide both of those by 7, and I end up with 5 over 3. If I compare 15 and 12, I can divide both of those by 3, and I end up with 5 over 4. So those guys aren't similar. My last pair that I can check is 1 and 3. So I'll check 35 over 15. I divide them both by 5. I end up with 7 over 3. 49 over 21. Divide both by 7, and I end up with 7 over 3. And finally, 28 over 12. I divide both of them by 4, and I end up with 7 over 3. So these guys are all the same ratio. So triangle 1 and triangle 3 are similar.